Hello friends, this is lecture number 4. This lecture depends on exercise 1.1. I will discuss the chain rule and examples depending on the chain rule which are asked in the board examination. Lecture number 4. Consider करणारे derivative of the composite function. Proof मी पुन्हा इथे घेणार आहे आणि यावर डिपेंडिंग असणार आहे आणि based on the exercise 1.1. Now let us start. First chain rule. If y is equals to f of u is a differentiable function of u and u is equals to g of x is a differentiable function of x, then prove that y is equals to f of g of x is a differentiable function of x and dy by dx is equals to dy by du into du by dx. आता हा theorem सगळ्यात जास्त important आहे. This theorem is very important. Number of the times बोर्डच्या एक्झाम मध्ये हा विचारला गेलेला प्रश्न आहे, थेरम आहे आणि यावर डिपेंडिंग असणारी एक्झाम्पल्स पण मी घेणार आहे. नाउ लेट अस स्टार्ट. वी विल प्रूव्ह दिस थेरम. Proof. Given that y is equals to f of u and u is equals to g of x, we assume that u is not a constant function. Let there be a small increment in the value of x. Say that increment is a delta x. Then delta u and delta y are the corresponding increment in u and y respectively. Okay. Next, as delta x, delta u, delta y are small increment in x, u and y respectively, such that delta x is not equals to 0, delta u is not equals to 0 and delta y is not equals to 0. We have delta y by delta x is equals to delta y upon delta u into delta u upon delta x. Taking the limits as a delta x tends to 0 on both sides, we get limit delta x tends to 0, delta y by delta x is equals to limit delta x tends to 0, delta y by delta u into limit delta x tends to 0, delta u by delta x. As a delta x tends to 0, we get delta u also tends to 0. U is a continuous function of x. Okay. Therefore, the limit delta x tends to 0, delta y by delta x is equals to limit delta u tends to 0, delta y upon delta u into limit delta x tends to 0, delta u upon delta x, and this is number 1. Next, since y is a differentiable function of u and u is a differentiable function of x, we have limit delta u tends to 0, delta y upon delta u is equals to dy by du and limit delta x tends to 0, delta u upon delta x is equals to du by dx, and this is number 2. Therefore, from 1 and 2 we get that the limit delta x tends to 0, delta y by delta x is equals to dy by du into du by dx. This is number 3. It means that the RHS of 3 exists and is finite, and it implies that the LHS of 3 also exists and is finite. And therefore, the limit delta x tends to 0, delta y by delta x is equals to dy by dx, and then this equation 3 becomes, what is that? Dy by dx is equals to dy by du into du by dx. Okay. Now next, question number 2. Now important examples from the exercise 1.1. This is the first example which has been asked in the board examination. If y is equals to sec root x, then find dy by dx. It has been asked in July 16 or the March 2. Now see this again. Y is equals to sec root x, differentiate with respect to x. Therefore, dy by dx is equals to, what is the derivative of sec of x? Derivative of sec of x is a sec x into tan x. In a similar way, derivative of sec of root x is a sec of root x into tan of root x. But here we want to find out the derivative of root x. And the derivative of root x is 1 upon 2 times root x. And therefore here sec root x into tan root x into 1 upon 2 root x, and this is the derivative of root x, and therefore dy by dx is equals to sec root x into tan root x upon 2 root x. Now next example, question number 3. If y is equals to tan square log of x cube, find dy by dx, and this example asked in March 18 for the March 2. Now the solution, let y is equals to tan square log of x cube, and this can be written as tan square. This is the main function, that is the tan of log of x cube bracket square. Now we will differentiate this. Now first we find out the derivative of this power function, that is the 2 times tan of log of x cube into ddx of tan of log of x cube. Now next, 2 tan of log of x cube into derivative of tan of log of x cube is a sec square log of x cube into ddx of log of x cube. That is a 2 times log of x cube into sec square log of x cube into. Now here we will find out the derivative of log of x cube, and this is the power. By using the rules of logarithm, we can take 3 here, that is a 3 times ddx of log of x, and what is the derivative of log of x? Is 1 upon x. Now see this next step, that is a 2 tan of log of x cube into sec square log of x cube into 3 into 1 upon x, and if we simplify this, that is 2 into 3, that is a 6 upon x, and the remaining as it is, that is a tan of log of x cube into sec square log of x cube, that is a 6 upon x, tan of log of x cube into sec square log of x cube. This is the dy by dx. Okay. Now we'll see the next example. Example number 4. Differentiate the sine of x square plus x with respect to x. This example asked in the February 20, and it is for the mark 1. Now the solution, y is equals to sine of x square plus x, u is equals to x square plus x. Therefore, it will become y is equals to sine of u. If we differentiate this, then you will get dy by du is equals to cos of u. Dy by du is equals to cos of, substitute the value of this u, x square plus x. Du by dx is equals to 2x plus 1. Okay. Now by the chain rule, see this here. By the chain rule, dy by du is equals to cos square x plus 1. Cos of x square plus x, and du by dx is equals to 2x plus 1. Therefore, dy by dx is equals to dy by du into du by dx. It's a cos of x square plus x into 2x plus 1. And therefore, dy by dx is equals to 2x plus 1 into cos of x square plus x. This example asked for the marks 2, not for 1 mark. Okay, now the next example. Question number 5. Differentiate log of sec x plus tan x with respect to x. This example is also for the March to February 20. Solution. Let y is equals to log of tan of x plus sec x, and therefore its a derivative dy by dx is equals to ddx of log of tan of x plus sec x, that is 1 upon tan x plus sec x, that is the derivative of log of x is 1 upon x. In a similar way, here 1 upon tan x plus sec x into ddx of tan x plus sec x, because it is a composite function. That is 1 upon tan x plus sec x, and derivative of tan x is a sec square x, and the derivative of sec x is a sec x into tan x. See this here? That is 1 upon tan x plus sec x into ddx of tan x, and the derivative of sec x is a sec x into tan x. In the next step, we'll write the derivative of tan x, sec square x plus sec x into tan x. Take sec x as a common, and then in bracket you will get sec x plus tan x. Sec x plus tan x and sec x plus tan x get cancelled, and here you will get dy by dx is equals to sec x. Okay, therefore dy by dx is equals to sec x. And in this way, we have completed the examples depending on exercise 1.1, which are asked in the board examination. Now we'll see in the next video. Till then, goodbye.